Hi guys, Mr. O'Sullivan here. Hey, we're going to take a look at some more differential equation problems. Now we're going to turn back time, go back to the 2001 exam, and I'm going to save problems 4 and 5 for you. Now those are kind of grab bag problems. They're not necessarily differential equation problems, but you're going to have to just kind of be aware of like what types of problems those are and work those out. I'm going to concentrate and work through problem number 6, which is a differential equation problem. Copied it here on the next page. And all three of these are no calculator problems. So here we go. The function f is differentiable for all real numbers. The point 3, 1/4 is on the graph of y equals f of x. And the slope at each point xy on the graph is given by the differential equation dy dx equals y squared times the quantity 6 minus 2x. All right. We just have to do two things. Part A, we're asked to find the second derivative of y with respect to x and then evaluate it at the point 3, 1/4. And then part B, find y equals x by solving the differential equation dy dx equals y squared times the quantity 6 minus 2x with the initial condition of f of 3 equals f of 3 equals 1/4. Okay, so part B, they're just asking us to find a particular solution for that differential equation. All right, let's dive in with part A. So part A, we're asked to find, again, the second derivative. So what we're going to do is start with first derivative, our differential equation, dy dx equals y squared 6 minus 2x. And in essence, what we have to do is take the derivative with respect to x of both sides of my equation. So on the left side, we get the notation for second derivative. Now to find the derivative of the right side of the equation, we're going to have to use product rule. So I'm going to break out my u's and v's. I'm going to call y squared u, and I'm going to call the quantity 6 minus 2x v. I'm just going to put u prime over here. U prime is going to be 2y dy dx. I hope you remember why we had to add the dy dx there. And then for v prime, that's just going to be -2. Now, if I just build the product rule, u prime v plus u v prime, and then I just pull in the proper information, 2y dy dx for u prime times v, quantity 6 minus 2x plus u y squared times v prime, which is -2. Okay. Now I see here that I have dy dx, right, as part of my second derivative. So what I'm going to do is I'm just going to make a substitution, and I'm given dy dx, that's my differential equation. I'm just going to take dy dx and substitute that in for the dy dx in my second derivative. So I'm just going to rewrite this. So d2y over dx2 is equal to 2y times, now I'm just substituting in dy dx, y squared times quantity 6 minus 2x times 6 minus 2x plus y squared times -2. Okay? Now, that is my second derivative, and now I want to evaluate it at the point 3, 1/4. So I'm basically doing the second derivative such that x equals 3 and y equals 1/4. I'm just taking that point that they've given me, and now I'm just going to substitute that into my second derivative. So I'm going to have 2 times 1/4 times 1/4 squared. Hope you follow what I'm doing here. Times the quantity 6 minus 2 times 3. That's my value for x. Brackets times 6 minus 2 times 3. Parentheses plus y squared. 1/4 squared times -2. Now, that hot mess right there is our answer. Aren't you glad we don't need to simplify a numeric answer? We'll leave that up to some poor AP reader to figure out that is correct. Okay, so that was part A, where we found the second derivative, and then we were given a point to evaluate the second derivative at that point. Okay, part B. It's kind of a moneymaker, pretty typical on a differential equation problem. We're asked to find a particular solution. All right, so we're going to start with our differential equation. dy dx is equal to y squared times the quantity 6 minus 2x. Okay, and I'm just going to make a note. My initial condition is f at 3 is equal to 1/4. Okay, so my first step, most important step, I want to make sure is my separation of variables. I want to make sure I do that correctly. So what I'm going to do is I'm going to multiply the dx to the other side of my equation. And then I'm also going to divide by y squared. So I'm going to bring that to the left side of the equation. So after I do that, I'm going to get 1 over y squared dy is equal to 6 minus 2x dx. Okay. Again, that's my separation of variables step. I'm just moving the y and the dy to the left side of the equation, the x and the dx to the right side of the equation. Okay. Okay, now my next step, I'm going to integrate. Before I integrate, I'm going to make just a rewrite on my left side. I'm going to rewrite this as y to the -2nd dy. Okay, yeah, not integrating yet, just did a rewrite. 6 minus 2x dx. Okay. Okay, now I'm ready to integrate both sides of my equation. So integrate the left and the right. When I integrate the left side, I'm going to have y. I'm going to add 1 to my exponent. So I'm going to have -2 plus 1 is -1, and then immediately divide by that new exponent. So I have y to the -1st over -1 is equal to, and then I'm going to take the antiderivative of the right side. So I'm going to have 6x minus 2x squared over 2. And I can cancel my 2's just to kind of simplify my life. And then I want to add my constant of integration, plus c. Okay. And what I'd recommend you do right now is I'm just going to rewrite that. I'm not going to do any algebra. I'm not going to change anything around. I'm just going to rewrite it the way it is. And I'm going to have y to the -1st over -1 is equal to 6x minus x squared plus c. Okay, now I'm going to remember my initial condition. That's telling me that when x is equal to 3, y is equal to 1/4. Okay. Okay, now I'm going to substitute that in. So I'm going to get 1/4 to the -1st over -1 is equal to 6 times 3 minus 3 squared plus c. All right. Okay, on the left side, my 1/4 to the -1st, I'm basically going to just take the reciprocal of that. And so that's going to be 4. So I really have 4 over -1, or just -4 to simplify things, is equal to 6 times 3 is 18 minus 9 plus c. So I have -4 is equal to 18 minus 9 is 9, plus c, subtract the 9, and I get c is equal to -13. Okay, I'm going to take this value, that's the value of my constant of integration, I'm going to plug that in for c. So now I'm going to rewrite my equation. So I have y to the -1st over -1 is equal to 6x minus x squared minus 13. Okay. And now all I have to do is just solve for y. So the first thing I would do, I'm just going to take care of this -1 down here in the denominator. So I'm going to multiply both sides of my equation by -1. So I'm just going to get y -1st is equal to, and I'm just flipping the signs on the right side. So I get -6x plus x squared plus 13. Okay, and then I have y to the -1st, which is 1 over y, is equal to my right side. And so what I want to do is I'm just going to take the reciprocal of both sides of my equation. So I'm going to get y on the left side, and then I'm just going to get 1 over -6x plus x squared plus 13. Okay, and that is my particular solution for this differential equation with this specific initial condition. Okay? All right, guys. Hope that helps. Thanks. Have a good one.